In this video, we will be talking about vector equations. A linear combination is a sum of scalar multiplied vectors, which kind of looks like A, which is a scalar, times a vector v1, plus B, a scalar, times vector v2, plus C, scalar, times vector v3, and so on and so forth. A span is a collection of vectors that can be rewritten in a linear combination. So it kind of looks like this. So C1, V1, plus C2, V2, plus C3, V3, so on and so forth. And the notation for span is just span, including V1, V2, as many as there are. If you're asking if a vector B is in the span of something, so if B is in span of V1 and V2, let's say, then the following is consistent. So x1 times V1 plus x2 times V2 equals to B is consistent. If B is in the span of V1 and V2, then x1 times V1 plus x2 times V2 equals to B is consistent, which means that it contains at least one solution. Basically, if the system of linear equations augmented with B has a solution, then B is contained in the span of those linear equations. Otherwise, it is not. Let's take a look at an example. So we want to rewrite the following vectors as a matrix and determine if B is a linear combination of them. So first we want to write these vectors as a matrix augmented with B. And now we want to determine if this matrix is consistent. So we just need to do some row operations. So we want to set row 2 to equal row 2 plus 2 times row 1. And we want to set row 3 to equal row 3 minus 2 times the new row 2. So let's first take a look at what this first operation right here will do. We'll end up with 1, 0, 5, 2, because nothing changes there. Now we want to set row 2 to equal row 2 plus 2 times row 1, which will end up being 0, 1, 4, 3, and then row 3 remains the same for this operation. Now we want to do our second equation right here, which will end up with 1, 0, 5, 2, same, 0, 1, 4, 3, which is the same. And now row 3 will equal row 3 minus 2 times row 2, which will give us a row of all zeros. Great. Now we want to solve for x1, x2, and x3. So you get x1 to equal 2 minus 5 times x3, x2 to equal 3 minus 4 times x3, and x3 to equal 0, which means that x1 is 2, x2 is 3, and x3 is 0. So we found two things. We know that this matrix is consistent because we are able to find these values of these variables. And because it is consistent, we can determine our second thing, which means that B is a linear combination of the vectors, which means B is contained in the span of V1, V2, and V3.